Good morning, sports fans. It is time for empirical and molecular formula notes. Start with a molecular formula. Molecular formula for glucose. It's probably something you learned in biology and you've seen me use it. C6H12O6. Molecular formula means it's a molecule. If we are talking about sodium chloride, this is not a molecular formula. This is a formula unit because it's ionic, right? So, ionic compounds are already in their simplified form. Okay, their simplest ratio. Okay, these are called empirical formulas. That's the definition of empirical formula. Covalent compounds, because it's a molecule, you can't write it, you can't simplify it. If you did, you're going to get what we call the empirical formula. The empirical formula for glucose would be CH2O, because we can divide all of those by 6. That's what we're talking about here. So the empirical formula is the simplest ratio of atoms in a molecular formula. Okay, example, the one I just gave you, C6H12O6, would be, the empirical formula would be CH2O. They're the same ratios. If we did peroxide, hydrogen peroxide, its simplest ratio would be HO. The molecular formula is the formula from a covalent compound. Some molecular formulas can be empirical. And then I'm going to have you add on all ionic is empirical. Why, you ask? Do we need to know the difference between empirical and molecular? Aren't we just going to be given it? Well, the answer is not necessarily. You guys have all seen shows like CSI. On CSI, not CSI, NCIS, they have Abby Shuto, and she is the tech, and they bring back samples from crime scenes, and she feeds it into major mass spectrometer, and he spits out information for her. And what he spits out is the percent composition, the last set of notes, the percent composition for whatever chemical was found at the crime scene. Okay, if they found glucose at the crime scene, it would spit out percent composition, which is what we just did. And then you would use that information to find the empirical formula. So, this is how we do empirical formula. We have a lovely little poem. And the poem goes, percent, because remember you're going to start with percent composition, to mass, mass to moles, divide by small, multiply till whole. Okay? Let's do an example. If you have a compound of barium and chlorine, 66% of it is barium, 34% is chlorine. Okay, if we follow our poem, the first thing we have to do is change that percent to mass. Now, this is the hardest thing you will do in chemistry. All right, you're going to write barium down 66% and chlorine down 34%, and then you're going to erase the percent and write grams. That's the first step. Hardest thing you'll have to do this year. Second step, you're going to change that mass to moles. So you're going to divide 66 grams by 137.33, because that's the atomic mass of barium, the molecular mass from the periodic table, and divide it 34 divided by 35.45 grams per mole because that's the molar mass for chlorine. Okay? Now I'm going to save you the calculation. If we do that division, you should get 0.4805 moles and 0.9591 moles. Okay, so now we have a ratio, this amount to this amount. But ratios make much more sense when you can have a whole number. So if we divide both of these by the smallest, which is 0.4805, we'll get whole numbers. And we'll get a whole number of 1 for the barium and 2 for the chlorine. It actually comes out to 1.99, but round to 2. So that means the empirical formula for that is barium chloride. And that's an ionic compound, so that makes sense. Barium has a +2 charge, chlorine each has a -1. You've done that. All right. So if I go back and I put the colors in, I did mass to moles in red. I divided by small, in blue. And we didn't do multiply till whole because we didn't need to. We got whole numbers. All right. All right, moving on. We are going to do the next one that has aluminum, 12.67 grams, or percent. Nitrogen, 19.73%. And oxygen, 67.60%. Remember, Abby's put this into major mass spectrometer. It has spit this information out. It tells us the percent composition. Now we're going to figure out the empirical formula. Okay, first thing we have to do is we have to change percent to moles. I didn't mean to erase that. Next thing, and change it to, percent to mass. We changed it to mass. Then we change it mass to moles. I'm going to change colors. The molar mass of aluminum, 26.98 grams per mole. Nitrogen, 14.01 grams per mole. Oxygen, 16.00 grams per mole. That gives us 0.4696 moles of aluminum, 0.9591, no, that was the wrong one, 1.408 moles of nitrogen, and a whole lot of moles, 4.225 of oxygen. Okay? It's always easiest if we can use whole numbers. The easiest way to make whole numbers is to divide by the smallest. The smallest is 0.4696, so obviously that's going to be a whole number of 1. If we divide 1.408 by 0.4696, we get 2.99, which rounds to 3. If we take 4.225, divided by 0.4696, we get 8.99, which rounds to 9. This means our final compound has 1 aluminum for every 3 nitrogens and every 9 oxygens. We know N and O can make groups that are polyatomic, and in fact that is the formula for nitrate. Aluminum has a +3 charge, so we can rewrite that bad boy, aluminum nitrate. Our last one, we have, instead of percent, we've already changed it to grams. So we have 0.144 grams of manganese. We have 0.074 grams of nitrogen and 0.252 grams of oxygen. All right, we don't have to change it to mass. It's done. Now we're going to divide by the molar mass. Manganese is 54.94 grams per mole. Nitrogen is 14.01 grams per mole. And oxygen is 16.00 grams per mole. That, I'm going to raise that up a little bit. That's going to give us 0.00262 moles of manganese. 0.000528 moles of nitrogen and 0.01575 moles of oxygen. To get to a whole number, we divide by the smallest. 0.00262 is the smallest. That's going to give us a difference of 1. 528 divided by 262 gives us a difference of 2. And 0.01575 divided by 0.00262 gives us a difference of 6. So our final ratio here is Mn manganese, 1 manganese, 2 nitrogens, and 6 oxygens. Here's our friend nitrate again, MnNO3 2. Name of this compound, therefore, is going to be manganese 2 nitrate. Okay? Let's see. I think we will stop there. Have a great day.